Hello ladies and gentlemen, this is Mr. Santora, and this lesson is being brought to you directly from the math office at Garden City High School. We're going to be looking at evaluating the limit algebraically. We found that we can find the limit pretty easily from a graph. However, we don't always have a graph, or sometimes the values are too large and we can't really sketch the graph. So we can find the limit algebraically using one or more techniques, and we may have to use two techniques to evaluate the limit. So let's take a look at this. First technique is direct substitution, and we're looking here to evaluate the limit as x approaches some value of a in the function f of x. So what you do is you take the a down here, the number under the limit symbol, and you substitute it into the function where the x appears. So if we look at our first example, we're looking to evaluate the limit as x approaches 2 of the function 2x squared plus 3x minus 5. So the first thing you do is you take the value under the limit symbol and you substitute it into the function where the x's appear. So you evaluate that, and if you get a real number answer, if it's a real value, there's your limit. So the limit of this function is 9. So now let's take a look at another example. We're going to be looking at the limit as x approaches 2 of the function x squared minus 4 over x minus 2. So again, we do a direct substitution, and we find that we wind up with 0 over 0. And this function is said to be in indeterminate form, and the method of direct substitution does not work. So when you get something like, when you get 0 over 0 and it's an indeterminate form, then we have another technique which we'll be getting to in a minute. But let's do a little practice with this. So if we're looking at this function, the limit as x approaches 3 of the function x squared. You put the 3 in for the x, and 3 squared is 9. That's the limit of the function. If we look at number 2, we're looking for the limit as x approaches negative 4 of the function 6x over x minus 2. So you take the negative 4 and you substitute it in for the 6 into the x in the numerator, so 6 times negative 4, and you substitute it here in the denominator, negative 4 minus negative 2, excuse me, and you wind up with negative 24 over negative 6. So the limit of this function is 4. We got real values. That's the limit of the function. Now let's see what we have to do with this example number 2 over here, if we get an indeterminate like we did here. So we need an algebraic or simplification method, or simply dividing out. So what we're going to do is try and reduce the function algebraically, then use direct substitution. So on this first one, the first thing we would do is factor the numerator and the denominator. So x plus 2 times x minus 2, because the numerator is the difference of two perfect squares, and the denominator is x minus 2. The x minus 2's cancel each other out, they divide out, and we're left with x plus 2. Now we do direct substitution. So we're looking to find the limit as x approaches 2 of x plus 2, and when we substitute in, we find that 2 plus 2 is 4. That's the limit of the function. So if you need to go back and replay this, replay it at this point. But the factoring that we've been doing now is going to be coming into play because we need it to reduce the fractions for the to simplify the limits. So let's do a practice problem. We're looking to find the limit as x approaches 5 of the function x squared minus 25 over x minus 5. So when we do a direct substitution, we find that we'll have an indeterminate form. So I've already looked at that. So we need to now go to dividing out. Sometimes the problems will give you instructions, find the limit by simplifying or dividing out. So if we look at this, you factor the numerator, x plus 5 times x minus 5. Denominator is x minus 5. The 2x minus 5's divide out, so now we're left with x plus 5. And if we look at the limit as x approaches 5 of x plus 5, we find out that the limit of this function is 10. So if you need to go back and replay any of these, do so now. We'll be going over this again, and we'll be doing practice problems in class. So thanks for tuning in to the first lesson of evaluating a limit algebraically.